Hello everyone. Let's start solving the organic questions of JAM 2019 question paper. So we are going to solve the first question, whichever it is for the organic part. Okay. So the first question says the correct option for the major products in the following reaction is. So you have alpha halo ketone. You can see here ketone is there at the alpha position. You are having halo, and then you are using a powerful base, that is sodium ethoxide, in the solvent ethanol, and they ask you what is the product form. So whenever you see a molecule like this, you should know the reaction is Favorsky rearrangement. So how this reaction goes is like this. If you see this ketone group, alpha to this carbon is there, the proton on it is acidic to a certain extent. Why? Because if you remove this proton, you get negative charge on this carbon, and this negative charge gets stabilized by resonance through this. So what I have shown is this ethoxide takes away this proton. This electron which would have come on this carbon, so that it gets negative charge, that I am showing delocalization over here. This goes up, you get negative charge on oxygen, and then it comes back, you get negative charge on this carbon. So now this carbon will undergo nucleophilic substitution reaction. This negative charge, it will go and attack this carbon alpha to this C-double-bond-O and forms a Cl minus leaves, and you get a 3-membered ring. Now 3-membered ring is kinetically favored, very fast it happens because quite close attack is favored, but it is not stable. Then what happens next step? The ethoxide ion attacks this carbonyl group, and you get this OET attack. So OET comes here, this C-double-bond-O comes here, and you get O minus, and that's what you get here, O minus. Now what happens? Now this O minus comes back, then this 3-membered ring opens up. Now you can see here it is a very it's an identical ring from either side. There is no substituent on either side, so it will open from both sides. So if this comes down and this bond opens up, that means this bond breaks, it will take proton from the solvent being ethanol, polar protic solvent. So it takes proton and ethoxide goes out, so you get COET on the starred carbon. Whereas if this comes down and bond opens up from this side, right side, it takes a proton and you get starred here on the alpha position, you get COET. Therefore the answer is option number C. Option number C is this 5-membered ring. You are having star on the COET carbon and alpha to the carbon which has COET. Right. Moving to the next question. The next question says the major product formed in the following reaction is. So you have a oxime in presence of acid. This is a very famous reaction called as Beckmann rearrangement. So you are having basically how it works out is, how reactant is formed is, you have ketone, you react with NH2OH. So H2O is lost and you get this oxime, and then you add H plus. So when you add H plus, first thing happens is it protonates and you get OH2 plus. Okay. Now Beckmann rearrangement, remember very clearly, when OH2 plus leaves as water, so the alignment of the orbitals has to be in such a way so that bond which is trans to this OH2 plus only reacts. Why? Because the anti-bonding orbital of this has to interact with the bonding orbital of this CC bond, and because that has to happen, for that to happen, the both orbitals, the anti-bonding and the bonding orbitals, have to be parallel to each other, so the bond have to be trans. So once this OH takes proton, you get OH2 plus, and then this double bond moves in, it gives anchimeric assistance, and this bond moves. Never ever this bond will move. Okay, never ever, whatever happens, this will not move because orbitals don't match. So this will move out and this goes out. So what happens? This bond is moving, so this carbon gets directly attached to nitrogen. You get nitrogen here, and then OH. Sorry, I think I missed one step here. I should have written here. Then after that, water attacks. After that, water attacks here. You get C triple bond, and then once water attacks, you get OH, and then this comes down, this comes up, and you get this oxime. So the answer is option D. So please remember what has happened is trans moved. So because trans moved, the bond whichever is moving on that nitrogen is there, and on the neighboring carbon you get C double bond O. Okay, so this carbon which has double bond O, that gets C double bond O, because every time you don't have much time when you're writing competitive examination, so you have to be fast. You can't write mechanism every time. So just see whichever is trans, that will get attached to nitrogen, and the neighboring carbon gets C double bond O, right? So this is option D is the correct answer. Next question. The major product formed in the following reaction. So you are having this non-Bornell kind of system, and you are reacting with metachloroperbenzoic acid. Now MCPBA, it is called as per acid, okay, perbenzoic acid, peroxy acid. So peroxy acid basically does two kinds of reaction. One is epoxidation reaction, one is Baeyer-Villiger oxidation. So epoxidation of alkenes means once alkene is there, it will form epoxide. Baeyer-Villiger, we need carbonyl group which is not here. So we understand it will first undergo epoxidation reaction. So what happens? Epoxidation mechanism is little tough. Just see, understand, this will accept electrons. Alkene gives electron, okay, alkene is electron rich center, so it comes and attacks here oxygen, then this gets out, and this takes away proton from this, and this you get negative charge, and this goes and attacks here, and you are getting this epoxide. Now what happens? You know, 3-membered ring is thermodynamically very unstable. It has to open up. So for opening up, you understand, this has to open. So this anti-bonding has to be attacked by the bonding orbital. Now which bonding orbital will attack? Again, which is anti-periplanar, which is the bond which is parallel. So this bond is there, this bond is parallel. So this bonding orbital will interact with this anti-bonding orbital, so that this opens up. I hope I am making sense. So yeah, whatever I said is here. You need this bonding orbital to interact with this anti-bonding. So this OH is there, this gives anchimeric assistance. I have shown in single step, but you can do in 2 steps. First the oxygen lone pair attacks, and then oxygen gets positive charge, and then proton is removed. Otherwise, if you have enough practice, you can write like this. So OH, this bond comes in, and this bond breaks, this goes and attacks here, it opens up, and you are getting this product. Okay. Now if you see the products, none of them look similar to this product. So I have to open up and check it out. How do we do it? So I just gave the number 1, 2, 3. So here 1, 2, 3 OH put up, because I saw something like this molecule here. Yeah, this is, I saw like this, I could correlate, it was like this, and 1, 2, 3. So it was 1, 2, 3, and then you see here what happens at position 3. You are having 9, so that 9 is becoming the, see this bridge. This bridge is there, so this 9 is the bridge, and then others is quite clear. 4 is oxygen, C double bond O, 5 is methyl, like this it happens. So the answer is product B. Okay, please practice it. It's quite easy. Next question. The proton NMR spectrum of the given molecule in the correct order of chemical shifts in the label proton. So higher the chemical shift means more deprotected it is. Okay, if it is more de-shielded it is. If it is shielded, that means nearby more electrons are there. If electron donating groups are there, then it comes at lower value. But if electron withdrawing groups are there, then what happens? Then electron is being pulled away, so they are de-shielded, so they come at higher value. Now let us look at this. It is like CH3 here, okay, and here CH2 is there, and here this is there. Please understand, all of them are quite de-shielded. Here proton is attached to a carbon which is sp hybridized. Okay, sp hybridized is carbon is more electronegative than sp2, which in turn is more electronegative than sp3, because sp means 50% s character, and whereas sp3 will have 25% s character. S orbital is closer to nucleus, so s orbital is pulled more strongly towards electron, and therefore it is more electronegative. So this also will come at quite high value. But if you look at Y is on the carbon which is next to sp hybridized carbon and also next to oxygen. Okay, so this Y looks definitely much higher value than Z. And if you look at X, this hydrogen attached to carbon which is attached to oxygen. Now oxygen is any day much more electronegative, much more electronegative than sp hybridized carbon. Sp hybridized carbon is very little electronegative. just that it is more electronegative than sp2 and sp3 hybridized carbon. So this will be higher than Z. So I would say xy is greater than hy is greater than hx, which in turn is greater than hz. So hy is greater than hx, yeah. So D should be the answer. Whatever I said, I must have written here. You can read it slowly. Okay. So the answer is option number D. Question number 5. Okay. So this will be last for this video. The question says, in the following reaction D-glucose, the product formed is. So you are having D-glucose. You are first reacting with bromine water. So bromine water is light. It's a mild oxidizing agent. Okay. And then second, you are adding H2O2 and Fe2SO4 thrice. So this is Fe2SO4 thrice is Fenton's. H2O2 and Fe2SO4 thrice called as Fenton's reagent. Okay. So let's look what happened. So this is a classic case of what is called as Ruff's degradation. So glucose, think about it as open chain structure. Okay. Once you add bromine water, this CHO gets oxidized to COOH. Okay. And then what happens when you add Fenton's reagent? This COOH is lost as CO2, and this HOH, this gets oxidized, this alcoholic part gets oxidized to aldehyde. So basically what has happened is the stereochemistry at carbon number 2 is lost and carbon number 1 is completely lost, and rest 4, 1, 2, 3, rather, yeah, rest 3 electronic, absolute stereochemistry remains same. Final was anyway achiral. So it says, among these molecules, which of them are giving the same product what glucose gives by Ruff's degradation? So very clearly, when glucose underwent Ruff's degradation, it gave this product. What is the product? From glucose, remove this first CHO because that gets oxidized to COOH and then CO2 is lost. Second becomes CHO. So here also stereochemistry is lost. So what you have to look is 1, 2, 3. 3 carbon stereochemistry has to be retained. So let us look at it. So what we have from down, let us look. CH2OH will be common for all of them. Then 2 OH on right side and 1 OH on left side. So this one is not right, and this one is also not right. Yeah, this one looks right to me because 2 OH on the right side, 1 OH on left side, and this also not right. So P has to be answer because B, if you oxidize first Br2 H2O, this will become COOH. Next step, this will be lost, and then this becomes CHO. So in glucose, this OH was this side on the right side, whereas this in the molecule B, OH in the left side. We don't care. Why? Because this is becoming CHO, so there is no stereochemistry involved. Later down part, all of them, both glucose and this molecule, had the same stereochemistry, and therefore it is retained. So B is the answer. So what you have to know is, first you have to understand the stereochemistry of D-glucose. Please remember it, see to it, and remember because they have not given you the structure of glucose here. Okay. This one is basically mannose actually, because at carbon number 2, mannose and glucose are epimers. At carbon number 4, glucose and galactose are epimers. So at carbon number 2, glucose and mannose will have different stereochemistry, and for galactose everything else will be same, but at carbon number 4, so 1, 2, 3 and 4, at 4th position carbon and galactose stereochemistry is different. So for glucose, let us just little bit to reminder for you. So you start with CHO, first OH is on, actually this OH we can, yeah, right, this first OH is on right side, then left, then right, CH2OH. Okay. So this you have to remember. So that's it for today. Thank you very much.